It's fine. So, hi everyone. My name is Antonio Viggiano. I'm an independent security researcher, and I'm currently working on audits and tooling. One of these tools is Fuzzy FYI. It's a automated fuzzer on the cloud. So today I'm going to show a comparative analysis of fuzzers effectiveness. And yeah. So for this talk, I'm just go through a brief introduction of how a fuzzer works and how to measure an effectiveness, the performance of a fuzzer, what would be the methodology for that, and some key takeaways. Yeah. So first of all, yeah, like from a high-level overview, a fuzzer will just throw some random inputs into your code and try to break it. But going a step further, we can think of it as like you start with some random value and maybe a corpus of previous transactions, maybe previous input that you have sent. Then until you are satisfied, maybe you have breaked some invariants, maybe you have crashed your program. You will pick one of those observations, you will mutate them, and if they are interesting, you kind of add them to the list, and you do that until you are satisfied. So maybe you reach a timeout, and maybe you find a bug. So yeah, naively, we can already think that all fuzzers kind of are equal because they will just throw random input, but that might not be the case since all of these functions and these kind of bold functions here, they might influence on the performance of or effectiveness of a fuzzer. So yeah, so like measuring how well a fuzzer can be at finding bugs is challenging. So first of all, because it's inherently random, and also because the performance can vary a lot depending on the run. So you might find a bug or bugs in the beginning of your campaign, or maybe like after many hours. Also, because like it's difficult to compare different fuzzers, because how do you know that you've found a bug? And finally, because yeah, so there are different ways of measuring like performance. So some solutions that are proposed here, they come actually from a paper shared by some folks from 12-bits. So like the methodology suggests not using the average, like average time to find anything, because of the randomness, you might have very different results from run to run. So you should definitely compare medians and standard deviation across different runs. Trying different seeds, so depending on the seed value, you can have different results. And also depending on the test environment. So maybe you are running on a multi-core instance, or maybe on like just a single worker, you can have different results. Also, it's important to fuzz over long hours, like not over only like a few runs, so that you can have a very wide range of values tested. Yeah, you should definitely try to look for unique bugs, so not double counting the bugs or the inputs that will make your code crash, basically. And also using a statistical test so that you can like make sure that your observation is accurate from a statistical point of view. Yeah, so here the research that I've done is basically comparing Echidna, the latest version, and Foundry using on Uniswap v2. So basically, we injected different bugs on Uniswap, like 12 different bugs, and we measured the time to find invariants that would break under these bugs. And then we run them for 30 different seed values, and we set a one-day timeout, 24-hour timeout. And finally, we compare the median of those times to break those invariants, and we use this statistical test to assess which median is lower than the other under a specific confidence level. And here is an example more in depth of what that looks like. So basically, on the left-hand side is an instance of the mutated code. So basically, when you're providing liquidity to Uniswap, you need to make sure that you are providing the same value of tokens, of both tokens. So on Uniswap, you take the minimum value of both tokens that you're providing liquidity to make sure that you incentivize LPs to not imbalance the pool. So a mutated code, like with an injected bug, would be taking the maximum value instead of the minimum value. So this is like an example of a manually injected bug. And on the right-hand side is like what we are doing for our Foundry tests and Echidna tests. So basically, we have a add liquidity fuzz test, and then we check if any of the Uniswap v2 invariants break. So for example, one invariant is that whenever you add liquidity, you increase K, and also adding liquidity increases the total supply of LP tokens and many more other invariants. So we have 22 invariants. And if any of those break, then kind of there's a bug. And here are the results from this study. So I'll just take some time to understand the chart here. But basically, on the vertical axis, we have the time to to break any of those invariants for the mutated code. And on the horizontal axis, we have all of these 12 different scenarios. So each one is a different bug injected there. So it's interesting, like from first insight, is that the results vary a lot. So some bugs are much harder to find than others. For example, like bugs number 6, 7, 8, 9, they are kind of very easy to find, and others not that much. The ones with the higher, with the bigger bars, and also the dispersion is not the same across different bugs. So for some tests, you might have a higher variance than for the others. And we can also see that the performance may not be the same for any of those fuzzers. And yeah, so here are some key takeaways. So basically, the performance can vary substantially from run to run. So if you are using a fuzzer, it will pick like a random seed by default, and it will use that seed. So depending on the seed, you should find you should break your invariant faster or not. So up to 1,000 times faster. Like that can mean either find a bug in 1 minute or 1 day. So you should definitely perform many runs and let your fuzzer run for many hours. And also, like Foundry will break invariants faster in some tests, Echidna in other tests. In other tests, it's not conclusive. So you should definitely try using more than one fuzzer. It's not that hard to do it. You should just change a bit your code. There is an example on the repo that I shared. And yeah, and that's about it. So if you have any questions about fuzzing or security in general, please reach out to me.
Thank you so much, Antonio.